Superposition in circuit analysis. Remember the definition of superposition. Summation of individual responses is equal to the response of summation of inputs. Okay. And graphically I can show like that. If you apply x1, you get y1. The same system. If you apply x2, you get y2. If you apply x1 and x2 together, you get y1 plus y2. Okay, that's it. Let's apply in circuit analysis. Consider a circuit like that. Okay, this value is V source 1. The value of this current source is I source 2. This is R1. This is R2. Question: what's the voltage? What's the voltage on R2? Okay. So you can analyze these circuits using many techniques. You can use KCL, KVL applications. You can use, to make analysis short, you can use node methods. You can use mesh methods. And similarly, you can apply the superposition. Let's apply. How to apply superposition technique? Superposition technique says apply the inputs individually. Inputs are sources. Okay? The inputs of the system are sources. The components are resistors. And we know that resistors, okay, resistors are linear. Okay? And let's apply the voltage source first and calculate V2. Response of V source 1. Okay, I will call it V2 V21. Let me say V21. V2 because of source 1. And then I will calculate the response of I source 2. Okay, I will call it V2 because of 2, second source. And then according to the superposition technique, I will say total V2 is equal to V21 plus V22. Okay? Now, let's find V21. V2 due to the voltage source. this is my circuit. While calculating the response because of a source, I have to turn the other sources off. Okay? Turn all dot vs1, okay, sources off. Only V source 1 should be on. So let me redraw my circuits, but before redrawing, let me explain what happens if you turn off a source. What does it mean, turn off? If you have a voltage source, turn off means adjust the voltage 0. And if you adjust the voltage 0, it will act like a short circuit. If you turn off a voltage source, it will be a short circuit. Okay? Voltage source short circuits if you make it off. And if you turn off a current source, it means adjust the value to 0 volts, 0 amps. It means there is no current. Okay, in any case, it will have no current. It will be an open circuit. It will be like an open circuit. You apply different voltages, but current is always 0. It's very similar to an open circuit. So current source is open circuits when you turn it off. Okay. So this is my circuit. I will turn the current source off. What does it mean? I will replace it with an open circuit. Let me draw. So only V source 1 is on. Okay. What's the voltage on R2? What's V2? Now it's V21. Okay. Can you help me? What's V21? This current is 0. No effect. They are only cables. V source 1 is a voltage source. Its voltage is divided on 2 resistors. There will be a voltage division. So let's apply the voltage division rule. Voltage division rule says voltage on a resistor is equal to total voltage source times its resistance divided by the total resistance. That's it. So this is V21. This is the voltage of resistor 2 because of only voltage source 1. Now, the second step, I will calculate the V2 due to the current source. So I will turn off the voltage source. Let me draw the circuit. If you turn off a voltage source, it will be 0 volts, short circuit. So now, what's the voltage of V2 because of the second source, V22? They are connected in parallel. You can combine them. The combination will be R1 parallel R2. If you redraw the circuit, this is R1 parallel R2, and V22 is the voltage of these points. Okay, V22. What's that voltage? There is a current source. I know the current coming from that source. I know the resistance. So what's the voltage of the resistor? Current times resistance. Okay. So I have calculated V22. I have calculated V21. So in my actual circuits, V2 is V21 plus V22, which equal to V21, this is V21, plus V22. Okay, so let's solve a numerical example. Use the same circuit and some values. Let this be 10 volts, let this be 5 amps, let this be 2 ohms. Okay, I am selecting values randomly. Let this be 10 ohms. Okay, I will analyze this circuit using two different ways. One is nodal analysis, and the other is superposition. Okay, let's analyze the circuit using nodal analysis. Let's analyze first using the superposition, and then to verify the result, let's analyze the same circuit using the nodal analysis. Okay, nodal analysis says select a ground. Okay, analysis with node methods. I have selected a ground and write the voltages. Let me go with a different color. If this is 0 volts, okay, this is 0 volt. What's the voltage of that point? A voltage source maintains a fixed voltage between two terminals. If you know one terminal, it's very easy to calculate the other terminal. If this is 0, there should be 10 volts difference, so this should be 10 volts. I know the voltage of that point. I don't know voltage of this point, E. Okay? So there is only one node unknown. Let's write the node equation on E. This current, and this current. What's the current coming from this? Coming from 10 volts. Voltage difference 10 minus E divided by the resistance. That's the current coming from 10 volts. Then what is this current? Plus, it's a current source. It's very obvious. 5 is equal to exiting currents. What's the current going down? E minus 0 divided by 10. So let's analyze. If you multiply with 5 and if you multiply this with 10, 5 divided by 1, so 50 minus 5E plus 50 is equal to E. So 100 is equal to 6E is equal to approximately 16.7 volts. And as you see, what's V2 here? V2 is equal to positive side node voltage minus negative side node voltage. V2 is E minus 0. So I have calculated E, which is equal to 16.7 volts. Okay, let's analyze the same circuit using the superposition analysis using superposition. Okay, let's use the superposition. It says apply the inputs individually. There are two inputs. Input 1, X1, input 1 is 10 volts, X2 is 5 amp source. make only 10 volts work. Okay, only 10 volt source will be working. Now this will be the V21. Okay, calculate V2 now. V2, there is a voltage division here. V2 is the voltage of 10 ohm, so V22 is equal to total voltage times the resistance 10 ohm divided by the total resistance 10 plus 2, okay, which is equal to 8.3 volts. As you see, it's very easy, just one equation. If you apply superposition, no equations, no difficult equations, very easy. The second step, make only 5 amp work. Now it's very important, when you turn off a current source, it will be an open circuit. When you turn off a voltage source, it will be a short circuit, not open. Now what's V2? To calculate V2, V2 is the voltage between this point and this point. Okay, I can combine two resistors. If I combine two resistors, the circuit will be like that. 5 amp to 10. If you combine them, 20 divided by 12. Okay, multiplication divided by the summation. And what is this voltage? V22 is current times the resistance. Okay, what's that? Volts. Okay, so what's V2? V21 plus V22. It's a chance, okay? I haven't considered anything. It's a chance. By chance, the voltages due to different sources is same in this circuit. Okay, what's equal to? Actually, these are 3, 3, 3, 3. Okay, so yes, 6, 6, 6, 6. So you can make an approximation, which is 7. Okay, look, V2. Calculated V2 using the superposition is 16.7, and let's look at the result using the nodal analysis. Okay, they are the same. If you use the mesh method, be sure that you will find the same value. Consider a circuit. It has, for example, more than 2 sources. Okay. How can you find the voltage E? You can apply any method, but in superposition, using superposition, you have some steps. The steps, number of steps, is equal to number of steps is equal to number of independent sources. So if you say V source 1, V source 2, R1, R2, R3, I source 1. Okay? To analyze that circuit, you will do this. Step 1. Step 1. The circuit. You will only make work one source. So let me work this source. Okay, so this was a voltage source. If you make it off, if you turn it off, it will be a short circuit. This was a current source. If you make it off, it will be an open source. So in this circuit, you will calculate voltage E. It will be E1. Okay, it's not the actual E. It's some partition of E. Okay, some portion. The second step, step 2. Here you will calculate E1. Okay. Here you will calculate E2. E2 is the voltage of that point because of the second source. Let's make the V source 1 off. If you make it off, if you turn it off, it will be a short circuit. It will be a short. And if you turn the source 3 off, it will be an open circuit like that. In this circuit, you have to calculate E2. Okay? Then, the third step is, step 3 is, the same circuit, you will calculate E3 now. E3 is the voltage because of only this third source. You have to turn the other sources off. This is a voltage source. If you turn it off, it will be short. This is a voltage source. If you turn it off, it will be a short. Then you will calculate E3. And at the end, what's the voltage E? Voltage E is equal to E1 plus E2 plus E3. Okay? If it is easy for you, if it's easy to apply superposition, you can apply. Okay? Then, how can you apply superposition with dependent sources? Consider the circuits. Okay. For example, this current of this resistor R1 is Ix. This is R2. This is voltage source 1. This is current source 1. Value is current source 2. Sorry. Let me give a different name, 2. And assume that this is C times Ix. C times. C is a constant value. Okay. How to apply the superposition? Assume that I wonder the voltage E. What's voltage E? Question. For example, dependent current source, dependent sources, current or voltage source, are not inputs. Okay? They are linear components of the circuits. Okay? So you will never turn them off. They should be always on. So this circuit, to analyze that circuit, you will have, remember, what will be the number of steps? Number of steps? Yes. Number of steps, number of independent sources. So you will have 2 steps. Step 1, you have to analyze the circuits. For example, first turn this source on and this off. You will calculate E1. But dependent source is working. It should be working. E1 should be calculated. Then, in the second step, this source is on and this source is off. Okay, this should be off. To make it off, I replace with a short circuit because it's a voltage source. Now I will calculate voltage E. It is because of the second source. Okay, let me call it E2. So the voltage E is E1 plus E2. Okay.